All right. So at this point, everyone should have all their supplies ready for science. You should have your water drop lab sheet. That was assigned Friday, but you should have it in hand. I'm going to show you exactly how to do the back side in class today. You should also have your science notebook. That's going to be key because we're going to be learning about the scientific method. You have a lot of really cool notes to record, but in amongst those notes, I have some really fun things for us to do, okay? So let's make sure we handle that well. So to get ready for class, let's do this. Let's all turn to our table of contents. Let's get ready for our note-taking today. We're going to write in today's date, which is September. We're in a brand new month. So it's September the 1st, September. And our title is Scientific Method. If you need to know how to spell it, it's right up here on the screen for you. And then you're going to go ahead and record the page number that you're writing this information on. Now it might be page 3 or 4 or 5, I'm not really sure, but just the next open page in your notebook, just write that page number down. All right, as you're getting your notebook ready, I'll explain what class will look like for you. Now that originally I had planned to give you guys a quiz. I am postponing that quiz. Sorry.
Oh yeah, I read that on the blue sheet.
You don't have to worry about the quiz today, okay? And the reason for that is because I want to get this lesson in so you know how to be successful on your lab and finishing that paper for tomorrow's homework. So we can do the quiz another time. All right, so we're not going to start with the quiz, but instead we're going to start learning about the scientific method. We're going to learn all the steps that it involves. And then what I'm going to do is take you through each step of the scientific method, pointing out how we use it, also pointing out how you used it on your paper, because you've already used the scientific method on here, haven't you? So we're going to see how you've been using it already. Thank you, Blair. Now, and throughout the lesson, we're going to stop and pause for moments. For example, we're going to learn what makes a good scientific question. What kind of question?
Scientific.
Scientific question. There's a difference in a scientific question and a non-scientific question. So you're going to help me out today in picking out good scientific questions. Also, we're going to learn what a hypothesis is. And when we get to hypothesis, I'm going to pull out or invite a guest to join us. It's an unusual guest, but our guest will be joining us, and our guest will be helping us learn what makes a good hypothesis. So make sure you're on your best behavior because we do have a guest arriving today, okay? You guys like guests in class?
Yes.
All right. So you'll get to meet that guest. And then what we'll do is finish up with all the steps of the scientific method, and we need to learn the difference between different types of variables. Now right now you might be going, what? What's a variable? That's okay, because we're going to learn in class. And after we learn in class, then you will know, you'll know exactly how to fill out the back side of your lab sheet. Yay! And you can do that on Wednesday for your homework. At the very end of class, I will give you your other homework for Wednesday. It's the scientific method handout. And in addition, on your way out of here, if you really, really, really want a copy of our blue sheet, then I have those printed for you, and you can pick one up over here by the door as you exit. I know some of you are just using Google Classroom, which is A-okay, but some of you really, really want a printed blue sheet. That's A-okay as well. So I've made prints for those of you who do want them, and you can pick those up on your way out. Okay? All right. Raise your hand if you're ready to learn about the scientific method. Oh, I love it. Everybody. Well, here we go. Let's get started with learning the scientific method. First of all, what in the world is it? You're going to be using it a lot this year. Let's define it. The scientific method is this. Now in your notes, you'll add the word the scientific method, right? And then you will add the definition. And the definition is on the screen for you. So the scientific method is an organized way of finding a workable solution to a problem. It's really a series of steps. A series of steps that you follow in order to be a good scientist. In fact, these steps are shown to you on the screen. You follow step 1, step 2, step 3, and so on. Now, here's the cool thing. You've already done this. You've already followed all these steps. In fact, if you look at your lab sheet here from last week, you had 5 steps. 5 steps that you followed to figure out a problem. So you've actually already done the scientific method. So what we're going to do is review how you used the scientific method, but also figure out how to do these steps well. All right. Now, notice the scientific method is organized. It's like a procedure. You followed procedures in entering this classroom, didn't you? You followed a series of steps. You came in the class. Everything's already sanitized. You didn't have to do that. But you checked the board. You got all your supplies ready. You got everything in order. You took a seat, and now we're beginning, right? That's a series of steps. The scientific method, same thing. A series of steps we follow to come to an answer. So, how many of you guys want to know these 5 essential steps? Of course you do. We all want to do the scientific method, right? So let's make sure we understand the steps well. Here they are, all 5 of them. Whew. Now I know that's a lot. You do need to write your 5 steps in your notes, but then we'll look at each one individually and see what they mean. Helpful on upcoming assignments and quizzes. Keep up the good work. Now the first step is to define a problem. Let's think about that. In your experiment that you did last week, there was a problem. In fact, on step number 1, it says, your question or problem, how many drops of water will a penny hold? That was your problem to figure out, wasn't it? Or your question. So you've already followed step number 1, defining a problem or asking a question. Now, if you've already done that experiment, remember I told you you could use other coins, didn't I? Use a nickel or a dime or a quarter to kind of change things up and make it fun. Now, who can tell me, what did you do on step number 2? You had the problem. How many water droplets will your coin hold? So what did you do for step number 2? Right here.
I formed a hypothesis.
Aha! You formed a hypothesis. You made a really good, educated guess, right? Okay. Let's see here. What was your hypothesis? I'm curious.
I got 30 on my hypothesis.
30 water drops. Wow. Was your hypothesis right?
I got 31 for my highest.
Oh, man. So it was really close.
Yeah.
But it wasn't perfect, was it? You know what? That's okay. In science, when you make your hypothesis, it might not be correct. In fact, it's usually wrong. But that's okay. All right. So let's look at these one by one, okay? First of all, defining the problem. Does everyone have all 5 of these in your notes? Okay. Defining the problem. Let's look at what it means to ask a good, solid scientific question. All right. No need to write this in your notes. But what does that mean? When we ask the problem, we're setting everything up to do an experiment, aren't we? Because we're trying to answer that original question that we had. Just like In your lab, you're answering the question, how many drops will a penny or coin hold? Well, a good scientific question does this. Let's all write this in our notes. A good scientific question is clear. Not only is it clear, it's also specific. And finally, it's something we can measure. It's measurable. So let's all write this down. This is like the definition of a scientific question. Now, here in a moment, I'm going to show you the difference between a non-scientific question and a good, solid scientific question. I think you guys can already do this. I'm confident in you. So I'll give you a moment to finish writing this, and then let's explore the difference. All right, so a good scientific question. Everyone is what? Clear, specific, and measurable. All right, I'm going to put some questions on the screen for you. You pick. I have option A and option B. Which one is scientific? And which one is not so scientific? Okay, here we go. All right, number one. We have 1A and 1B. 1A says, what is the best kind of hand sanitizer? Okay. 1B says, which hand sanitizer kills more germs? Okay. Of these two, raise your hand if you can tell me which one is the scientific question. Which one's more clear? Which one's more specific? Which one's actually measurable? Let's see here. Very back here. Yes. What do you say? B? Really? Give me a thumbs up if you agree with it. Awesome. You guys picked it out. That's the scientific one, isn't it? Look at A. What's the best kind of hand sanitizer? What does that even mean? What does best mean? Maybe it means the one that you think smells nice. Maybe it's the one that you say is the one that leaves your hands less sticky. We don't know what best is, do we? We can't test best, we can't measure best. So that's really not a scientific question. 1B is scientific. We can measure that. We can take some germs, use one hand sanitizer, use the other, do a swab, and figure out which one killed more germs. We can test that, can't we? All right. Number 2. Let's see if you can keep this up. Number 2, your two options are, does a squash have seeds? Okay. 2B, does a squash or a tomato contain more seeds? Which one's more clear? Which one's more specific? Which one's more measurable? Ooh. Right here. B? You're right. Now then 2A isn't a bad question actually. Does a squash have seeds? But it's just a simple yes or no answer, isn't it? I mean, all you have to do is cut it open and see. Oh, it has seeds. So you can do that. You can test that. But 2B is much more specific, isn't it? You can maybe take 10 squash, cut them open, count the seeds in each, average it out, and do the same thing with the tomato, and figure out which one contains more seeds, right? So yes, 2B is definitely the more scientific question. See what we're doing here?
Yes, sir.
Here's a good rule of thumb. If it's a simple yes or no answer, it's probably not a very scientific question. Okay? You guys want to try another one?
Yes, sir.
All right, let's try another one. You're doing great. 3A, how much rainfall does your hometown get each year? Or 3B, does it rain often in your hometown?
You should use the randomizer.
I could. Unfortunately, the randomizer is on my phone. So I can't use it right now. let's see here. I picked a girl last time. I'll pick a guy this time, okay? So, gentlemen. How about right here? Yes.
A.
You think A? Why did you pick A?
Because, it just like, trying to see the other one. It doesn't say like often, cause like, if on B it says, does it rain often in your hometown, that's not being very specific.
Ooh, yeah, often isn't specific at all, is it? Often might mean once a week. Often might mean once a month, depending on where you grew up. So this one's not very measurable, is it? It's not very clear. So 3A is much more clear. So you see 3A is the scientific question, right? Okay. One more? You guys good for one more and then we'll switch gears?
Yes, sir.
Okay. Last one, number 4, is swimming beneficial exercise? Or for B, does running 1 mile or swimming 1 mile burn more calories? Ooh. Blair?
B.
B? Why did you pick B?
Because A is a question you answer by saying yes or no, and B is not.
So simple yes or no question, right? B is much more specific, isn't it? All right, excellent job. All right, give yourself a pat on the back. You guys got all those. Or slap on the back. All right, we're going to skip this slide here. Let's go into a hypothesis. I love this part. This is where we're trying to answer our question. So let's define a hypothesis. So in your notes, let's write a definition for a hypothesis. It's when we make a really good educated guess to the outcome. So we try to answer our own question, don't we? But we may be wrong, and it's totally okay if we're wrong. Now notice a good hypothesis is based on gathered information. The more information you have about that topic, the more likely your hypothesis will be correct. Yes?
Is it like an inference?
It is. That's a great connection. A hypothesis really is an inference, isn't it? We're using our observations to make the best educated guess we can. New word of vocabulary, but it ties in with inference, doesn't it? Great point. Yes?
If you do an experiment, could said experiment have could you have multiple hypothesi?
You can. You can have more than one hypothesis. In fact, a lot of times you'll start with one hypothesis and figure out, ooh, that's way wrong. And you go back and recreate it. In fact, we're going to do that now. All right. You guys ready to meet my guest?
Yes.
All right. I have invited a guest to come join us in class today to teach us a lesson, a very valuable lesson. This guest will teach us how important information is in making our hypothesis. All right. So, excuse me while I get our guest. Our guest was hiding in the desk the whole time. All right. Everyone give it up. Give a nice Providence warm welcome to our guest, Jeannie. Jeannie lives in this bottle. This bottle is her home. Now then, Jeannie is of course teeny tiny. She's very delicate. I can't expose her to the light or she shrivels up. It's bad for her. So her home is this glass container, but it has a cloth covering over it, so she doesn't get too much light. And Jeannie's tiny. She has teeny tiny hands, but I have worked with Jeannie for a while now, and she can do tricks for us. So would you like to see Jeannie do a trick? All right, now you can't see her directly because she's in the bottle. But she can do tricks so that you can see that she is in the bottle. All right. So, I have here a pencil with a paper clip attached. Notice there's a hook on the end, right? Now what I'm going to do is I'm going to stick this paper clip on the pencil. I'm going to stick it in her home. And I'm going to ask her to take her teeny tiny hand and grab onto this little hook and hang on. You guys ready? Do you think Jeannie can do tricks? All right, Jeannie, please take your teeny tiny hand, hang on to that hook, and do not let go. Jeannie! Give it up for Jeannie! All right. Jeannie, you guys all believe there's a genie in this bottle, right?
Oh my
Sure, definitely.
All right, obviously we have been presented with a problem. Some of you, hopefully I tricked, you do think there's a genie in the bottle. I don't know, maybe not. Some of you are going, no, you're being silly, Mr. Whitaker. There's no genie in that bottle. Something else is going on. So we have a problem here, don't we? Our problem is, how in the world do items get caught in this genie bottle? How does that happen? All right, so let me show you just a few more times. And then what you're going to do is you're going to make your really good educated guess. You're going to create a hypothesis and tell me what you think is going on in this bottle. Okay, so I'll do it again. Jeannie, grab on with your teeny tiny hand and do not let go. Yeah, see. She's hanging on. Jeannie. All right. So right now, go ahead and in your notes, write down what you think is happening. Create a hypothesis. Yes, you can even fill it in this form. You can say, I think blank is happening because, yeah, everyone fill in a hypothesis. What do you think is going on? You think there's really a genie there, don't you? And the other class was asking if she'll grant any wishes, but she's on wishing vacation today, so she will not grant your wishes today. All right, so let's see. What kind of hypotheses are out there? What kind of educated guesses are you guys writing on your paper at this moment? What do you think's really going on? All right, right here. Yes. Really? So you think it's a logical idea that this metal paper clip would stick to a magnet inside that bottle? Okay, raise your hand if you also said you think there's a magnet in there. Okay. Who has a different hypothesis? That makes logical sense, doesn't it? Let's see, what other hypotheses do we have? Let's see here. Davis, what do you say?
I think that there is a pole inside it like this, and if you bit the paper clip to where it wasn't a hook and put it in, it wouldn't stay.
So basically like another stick in there like this with a hook? Is that what you're saying?
Either that or just like in the bottom there's a pole that
Okay. All right, so basically some kind of pole or another hook in there, right, that this hook can latch onto. Okay. So how many of you guys, raise your hand if you said there's probably another hook in there or a loop of some type. Okay. All right, a lot of you. Okay. Can we test your hypotheses?
Yes.
Yes, we can. You know that Jeannie will grab this. Let's try something else. How about this tool right here? This little tool that came out of my garage, one end has a wrench. Could a hook grab onto that wrench?
Yes.
Okay, all right. So let's try it. All right, Jeannie, they're not convinced that you're real. Please show them. Prove yourself. Take your teeny tiny hands and grab on. And don't let go. Oh. Huh.
Still could be a hook.
Okay.
the hook could be going through.
So a hook could grab onto this, couldn't it?
Yes.
Let's try something else. Let's try this end. This end is just basically like a screwdriver, a flat edge screwdriver. There's no hook. Now it is metal. So I'll stick this end in and see if Jeannie can grab on. All right, Jeannie, convince these young guys and ladies that you're real and grab on and don't let go.
It's exactly a magnet.
Oh. Okay. Now, So we kind of eliminated if it's a hook, another hook, right? Now, could it be a magnet at this point?
It'd be strong enough to hold it.
It could be a magnet.
Could be multiple.
Let's try something else.
A pencil.
Let's try a pencil.
That thing's
Now,
I
let's try this end first. Thank you. Thank you, Mr. Ogle, for believing in the genie. This end has metal, right? So let's try it first. All right, Genie, convince them. Grab on with your super teeny tiny hand and don't let go.
I don't think those things are magnetic though.
What is going on?
They're magnetic.
Hold on. This is metal,
Yes.
but this end of the pencil is not.
There's lead in
Lead.
that. There's lead.
This end of the pencil is wood with lead, but lead is not magnetic. So, let's try the other end. All right, Genie, grab on and convince these young men and women that you're real. Don't let go.
Oh, I think I figured it out.
What? Ah!
I know the answer.
Ah!
It's the only logical explanation.
And now the whole class believes that genies are real, right? Let me try one more thing. This one here is a piece of plastic. It's just a plastic stick. Kind of out of like flour, like fake flowers. So it's plastic. Would a magnet grab onto it?
No. Yes.
All right.
It's fused.
Genie, don't let go.
What? You shook a little bit.
I don't know.
What?
Shake it.
Shake it. I just don't feel about this.
Okay.
I know where ours are going.
So obviously we still have a problem here, don't we?
Genie, we're unbelievers.
We know there's no hook. We know there's no magnet.
No.
What is going on? So everyone right now, voices off. Go back to your hypothesis, rework it. See if you can figure it out. Write a new hypothesis. You're getting more information. You're discovering maybe your old hypothesis was wrong, which is okay. Write a new hypothesis. What do you think is really going on? I think there's a genie.
Wait, can we use that as a hypothesis? I think there's a genie in there?
Yes, you could.
You said that she can't.
That's the only.
Sully like
He's determined to make sure she exists.
I'm here.
All right.
I think so.
It's a
So,
girl.
I want to hear some more of your hypotheses out there. Who has, or they think they have the answer? Who is just, now if you've seen this stuff before, don't give away the actual. I don't think anyone's, Jackson, you may have seen this. Okay. So what do you think is happening here? Right here.
It might be, maybe there's like clay in the bottom of the cup and you can stick anything inside of it.
Oh, so something sticky, like clay.
But that can easily peel off because you can't see it.
Okay. So maybe there's like clay or something sticky stuck to the wall. We stick something in, it sticks.
Or it's like some type of glue or something.
Okay.
But the glue would
All right, so
Stay
something
on, yeah,
sticky
it's clay.
causing whatever items I stick in there to get stuck for a little while.
Yeah.
Okay. All right. We'll see. All right. Any other hypotheses out there? All right. Right here.
What if there's a hole in the side of the bottle and you're sticking it in at an angle and because there's like a bandana over it, you can't tell.
That's so it.
Ooh.
Has he been sticking it in an angle though? I don't think
All right.
yeah, he has.
You'd
Let me do something.
Yeah, we don't know for the little bird.
Here's what I want you to do. I want you to watch carefully. What I'm going to do, I'm going to do it a few more times,
Yes.
but have voices off. Listen. You might be able to hear something. And watch my motions. I always do the same motions every time. So watch my motions. I always insert something, but I don't just pull it out, do I? That doesn't work. I always insert something, tip it over, give a little pull, and then it gets stuck.
Will you pass around the genie?
Oh, you missed the listen part. Oh, you have to listen at the end, okay? Let me do it again.
You're tapping.
Listen.
Oh.
Did you hear something?
Something dropped.
Something dropped.
Something came up from
All right, here, I'll do it again. I'll do it again in case you missed the sound.
Down.
All right, it's really, really quiet. You have to listen really carefully. What is it? All right, you know?
It's a ball inside of it that's almost as big as the opening in the jar. And then when you tug it, it gets stuck in there. And you can hold it up, but then when you push down, it pushes the ball with it and it drops back in.
Huh. Let's try something. I want to try this. You think there's a ball inside
He's
here?
gonna hang the genie.
Oh, no!
Jackson!
Now, if there's a ball in there, notice I always tip it over, don't I?
Wait,
You said the ball's a little bit bigger than the glass end? So that's why the ball wouldn't roll out, right?
Yeah.
Now, if there's a ball, could you hear it when I shake it? Oh,
There's something in it.
It's because the genie's shaking
All right.
around in there.
Poor Jeannie, she just experienced brain damage.
My hands are tired.
All right. So let's try this. I want to stick in this side, it's the loopy side. I'll stick that in. If there's a ball, the ball should roll down when I tip it. Then I give a little tug, right?
Yeah.
And it sticks.
Bye-bye, genie.
Poor Jeannie. Now, what happened to the ball when I pulled it out? All right, let's watch. I pulled it out, but what happened to the ball? If it's a ball, I stick it in, tip it, ball, gets stuck. I pull, it's stuck there, right? Yeah. All right, now, if there's a ball there, really tight, let's see what happens. Listen really carefully. Notice I let the string go down and then pulled it out.
So it released some
It
kind of
pushed
tension.
it down.
They might have given the ball enough slack to fall down.
Or there's some kind of tension
Because when it doesn't have any slack, that's why you keep
You
it
got it.
hot the whole
What
time.
did he say?
It is. It is a rubber bouncy ball inside this glass container. The bottom is much larger than the top. To get the ball in, I had to force it in. Now, once it's forced in, I can stick any item in, tip it, cause the ball to catch, and voila.
Magic.
Genie's hugging you.
It's really just a genie.
All right.
The genie got
Wait, why?
So,
Open the bandana.
let's see here. The bandana, it's really difficult to get back on. So, all right. Now, everyone do this. Raise your right hand up in the air. And everyone repeat after me. I will not tell
I will not tell
my 7th grade friends
my 7th grade friends
about the ball in the bottle. I will only tell them about the genie in the bottle.
I will tell them about the genie.
All right, that's your promise. Don't give it away to the other class, okay? If you tell them, it's going to ruin the whole experience for them, okay? So don't tell them. You can just say, hey, we did something really cool. There's a genie in Mr. Whitaker's class. Don't tell them the trick, okay? All right, yes.
It's the ball. You should name the rubber ball genie.
Exactly.
All named genie.
It's a rubber ball named Genie, right?
The genie is in the bottle.
All right, yes.
Can we test it
Can we test it?
for ourselves?
I prefer not. If you don't get it just right, it will drop and break. So I don't. It's all right. All right, yes, right here.
For some reason, I expected for somebody to walk in painted all blue.
That would be funny. All right. Now then, let's focus 2, 1. All right, excellent job. The whole point of this activity was to show you the more and more information we get and gather, the better our hypothesis will be. Notice, everyone started off with an incorrect hypothesis, but that's okay. As you gathered more information, your hypothesis got better and better until we got it. All right, excellent job. All right, so let's move along here. You do not have to, that's another experiment we'll do maybe another time. All right, so the third step of the scientific method is the fun part. It's where we get to do the experimenting. Experimenting is simply testing our hypothesis. So let's define that. An experiment is testing our hypothesis. All right, everyone go ahead and write that in their notes. To test the hypothesis is called experimenting. Yes.
Can I use the restroom?
Emergency. Real quick, okay. This is the nearest one right here. All right, when we're testing a hypothesis and doing an experiment, there are variables that come into play here. And there are 3 types of variables. How many variables are there?
3.
3 different types. And you need to know these types because on the back side of your lab sheet from Friday, you have to do that as homework tomorrow, don't you? You have to tell me the types of variables from that experiment. So we need to define these 3 types of variables. How many? 3 types of variables. Here we go. In your notes, let's add a definition for each one. I'm sorry, it is a little lengthy, but we must have an understanding of what these are. Yes, sir.
I didn't see that we were supposed to write the variable down there, so I didn't finish it.
Oh, can you peek over and see your neighbors, please?
What is a variable?
All right, so we have 3 different types of variables, and here they are. We have dependent variables. Dependent variables are factors that get measured. So in your water drop lab, there was something that you measured, wasn't there? Who can tell us, what did you measure in your water drop lab? Right here.
How many drops of water you got in your
Exactly. So the number of drops would be the dependent variable, wouldn't it? That's what you're measuring. Now the next type of variable is called an independent variable. What's it called? An independent variable are things that you change. Things that you change within your experiment. Well, in the example of our genie in the bottle, we changed what we put into the bottle, didn't we? We have multiple items that we stuck in the bottle. Those would be independent variables, things that we changed. And the last part, we have control variables. These variables always remain constant, control, no change. They're locked down. So controlled variables do not change in an experiment. So in our example of the genie in the bottle, this bottle never changed, did it? We didn't change the shape of the bottle. We didn't change anything about the bottle. The ball inside never changed. So we would say that the bottle and the ball were controlled variables. They never changed at all. Yes?
What does the definition say for control on the bottom?
Oh, right here. I'm sorry. It's kind of low, isn't it? Control variables, they're factors that stay constant or the same in an experiment. You're welcome. Alright, so in your experiment, or your water drop lab, you'll answer the back side here, and you have to identify these three types of variables. The dependable ones, or dependent ones, the independent ones, and the control ones. Okay? Alright, so Wednesday homework. Finish your water drop lab, the back side. Also, you have this handout to complete over the scientific method. Okay? And I'll hand that out for you in just a moment. Alright. Have we covered all 5 steps? Almost. We still have 2 remaining steps, don't we? Step number 4 was to classify and analyze data. That's one that sometimes people forget. They get all fired up and pumped up about the experiment and then forget to write down the information. Well, you definitely had to do that in your experiment, didn't you? You had to write down and document all the data. How many drops fell and stayed on your penny or coin. So you did that step in your lab. Does everyone have this in their notes, by the way?
Yes, sir.